Here we are going over page 3 of homework 5 in unit 2 of geometry. So, given each definition or theorem, we want to complete the statement. So, for this, again, you should be looking at the 3 pages in the notes packet from 2.4 that are called properties of equality, which shows all of the different equality properties. The segment proofs reference, which shows all different properties of congruence, definitions, and postulates that have to do with segments. And the angle proof reference, which again shows definitions, postulates, and theorems that have to do with angles and lines and perpendicular and things like that. Okay, so by the definition of congruence, if angle D is congruent to angle E, then what? Well, we think back to what the definition of congruence allows us to do. The definition of congruence, notice it allows us to, so segments are congruent if and only if they have the same measure. And remember, the definition of congruence is also with angles. So it works for turning the measures of angles equaling each other back and forth with the angles themselves being congruent. So, if we're given that angle D is congruent to angle E and they want us to use the definition of congruence, then we can conclude that the measure of angle D is equal to the measure of angle E. So notice we went from congruence to equal sign. Number 2, definition of complementary angles. Well, let's go back and look at the definition of complementary angles. What does that do for us? The definition of complementary angles right here allows us to go between complementary and the sum of the angles being 90. So we know that complementary angles means their sum is 90. So this told us that the sum of the angles are 90. So therefore we can conclude that angles 1 and angle 2 are supplementary, or complementary, excuse me. Angle 1 and angle 2 are complementary. Exactly. Okay, number 3. We're using the definition of supplementary angles. So definition of supplementary angles and the definition of complementary angles are similar in what they allow you to conclude. Remember, the complementary angles allows us to conclude that if the sum of 2 angles is 90, then they are complementary. So the definition of supplementary angles allows us to go back and forth between 2 angles being supplementary and their sum being 180. Since supplementary goes with 180 and complementary goes with 90. So, by the definition of supplementary angles, if angle P and angle Q are supplementary, then the measure of angle P plus measure of angle Q equals 180, which is right here. The measure of angle P plus measure of angle Q equals 180. Okay, so next one, definition of a right angle. Definition of a right angle. Let's go back and find where that is. Definition of a right angle. We're on the angle proofs reference. Definition of a right angle means a right angle equals 90 degrees. So a right angle is 90 degrees. That's the definition of a right angle. So if the measure of JKL equals 90, then what could we conclude? Well, remember, a right angle equals 90 just means you can go back and forth between saying a 90 degree angle is a right angle. So if we're told that something is 90 degrees, guys, close the door, please. Then angle JKL is a right angle. Angle JKL is a right angle. Okay, number 5. The vertical angles theorem. Vertical angles theorem. Let's look back to the vertical angles theorem, what that tells us. If 2 angles are vertical, then they are congruent. So it allows you to basically say if angles are vertical, then they are congruent. So angles 3 and 4 are vertical, so therefore they are congruent. Angle 3 is congruent to angle 4. The complement theorem. Complement theorem. This one is a little tricky. Let's go back and see back what the complement theorem tells us. If 2 angles form a right angle, then they are complementary. So that's the complement theorem. If you're given that two angles form a right angle, then you can conclude that they are complementary. So right angle means complementary. So if angle S and angle T form a right angle, then they are complementary, meaning angle S and angle T are complementary. Angle S and angle T are, should say complementary right here. So notice what we're doing here. We're just using the different theorems to see what we can conclude based on our given information. So the supplement theorem, it's probably a lot like the complement theorem since they look a lot alike, right? Just like definition of complementary angles and definition of supplementary angles are very similar. Just one deals with supplements and 180 and one deals with complements and 90. The complement theorem and the supplement theorem are going to be very similar. The supplement theorem states that if two angles are a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. So if angle X and angle Y form a linear pair, then we have to say that they are supplementary. So angle X and angle Y are supplementary. Or angle X is supplementary to angle Y. You could say it either way. All right. Next, we've got the congruent complements theorem. Congruent complements theorem, which is very similar to the congruent supplements theorem, which we'll talk about in a second. So, if angle 1 is complementary to angle 2, and angle 2 is complementary to angle 4, then, congruent complements theorem says that if angle A is complementary to angle B, and angle C is also complementary to angle B, then A and C, angle A must be congruent to angle C. So basically, if you have two different angles that are both complementary with the same angle, so angles 1 and 4 are both complementary to angle 2, then we can conclude that angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. And then number 9, we're using the congruent supplements theorem, which is pretty much the same thing as the complements theorem, but instead of saying complementary, they say supplementary. So angle J is supplementary to angle K, and angle J is supplementary to angle L. So if two different angles are both supplementary with the same angle, then those two angles, K and L, must be congruent. So angle K is congruent to angle L. Okay, so that is the deal with those. So again, we're using their definitions to make conclusions and fit the conclusions with the given hypotheses. All right, let's look at this next one. Okay, so we're going to complete this proof. And this is an angle proof, so we're going to want to be using our angle proof reference. Angle proof reference. So, again, we need to, just like we did with the previous proofs, we need to go through and understand what each of these things mean. So, definition of an angle bisector. We haven't talked about that in a while, so we might want to go back and review that. Definition of an angle bisector tells us that an angle bisector divides an angle into two equal parts. Okay, so definition of an angle bisector allows us to conclude that if something's an angle bisector, then that angle bisector divides an angle into two equal parts. Okay, so we also have givens. We know what those mean. Transitive property, recall, that is on our properties of equality. We have the transitive property, which allows us to say that if A equals B and B equals C, then we can jump straight from A equal to C. And there's also a transitive property of congruence as well. It works the exact same way. If the first equals the second and the second equals the third, then you can say the first is congruent to the third. And then we have definition of an angle bisector. Again, that's the same thing that allows us to say that if an angle is broken into two congruent parts, then, or if an angle bisector divides an angle into two equal parts. So we're told that ray BE bisects angle ABD. Ray BE bisects angle ABD. So we should probably make markings on here. I can't write on this computer, but we should make a marking right there and right there to indicate that we know that ABE, angle ABE is congruent to angle EBD by something. We'll see what that means in a second. And then we also know BD, ray BD, bisects ray EBC. So that means those two angles are going to be congruent or equal. So, here we go. What allows us to say that ray BE bisects angle ABD? Well, the first step is always going to be given, so we know that, but we also know that this is written right here next to given, so that's what allows us to make that conclusion. So, it was given. Right down here at the bottom. Okay, so now they make the statement that angle ABE is congruent to angle EBD. ABE, so this angle right here, is congruent to angle EBD. So what allows us to state that? It's got to be something in here that allows us to state that. And guess what? Since it talked about being a bisector, an angle bisector, it is definition of an angle bisector that allows us to conclude that angle ABE is congruent to angle EBD. Because it just told us that that ray BE bisects ABD. It just told us that. Which means that those two must be congruent by the definition of an angle bisector. So again, remember, cross these off as you go. So we should cross off the first two, the top two. Given and definition of an angle bisector. All right, so next thing. Ray BD bisects angle EBC. This was also given. So we write given next to number 3. Okay, number 4. So number 4. So once we just said that, BD, ray BD bisects EBC, then it says we're able to make the statement angle EBD, which is this middle one, is congruent to angle DBC. We know that because BD was an angle bisector of EBC. So we know that number 4 by definition of an angle bisector. Definition of an angle bisector. So the only one left is transitive property. So we know the last one has to be transitive property. But let's see why it is. So notice if you put 2 and 4 together, you have the first thing is congruent to the second thing, and then that same second thing is congruent to the third thing. So we put those together, jump straight from first to third to say the first is congruent to the third, and that is the transitive property. Angle ABE is congruent to angle DBC, and that is the transitive property right there. So that concludes our video on page 3 of homework 5.